We are going to talk about how to predict the mass of products or reactants in a chemical reaction without having to know the concept of the mole. So here we go. We have a reaction here, hydrogen plus chlorine giving you HCl or hydrochloric acid if it's in water, or hydrogen chloride. It's going to call it hydrogen chloride. And what we need to know is, first of all, we need to know how to balance the equation. So I'm going to do that quickly for you. Okay, now the equation is balanced. The other thing we need to know is the atomic mass of our elements. So, for example, hydrogen has a mass of 1, but I can see that there's 2 hydrogen. And chlorine has a mass of 35.5, and I can see that there's 2 of them. So hydrogen in this equation weighs an equivalent of 2, whereas chlorine 71. And hydrogen chloride is 1 plus 35.5 times 2, so that weighs 73. Now, what unit? Unit's not relevant here because this is a ratio. What this is saying is that for every 2 units of hydrogen, that could be grams, we have 71 grams of chlorine, for instance, and 73 grams of hydrogen chloride. And that's your law of conservation of mass. Mass isn't created or destroyed in a chemical reaction. We could use this to predict the amount of chlorine required if we had an excess amount of chlorine and it reacted with 10 grams of hydrogen. So how much chlorine would we need? I'm going to call that X. And how much hydrogen chloride would we get? Call that Y. So what we need to figure out is, what is our ratio? So our ratio of hydrogen to chlorine is 2 to 71 according to our reaction. And if we need 10 grams of hydrogen, how much chlorine would have to react with it? So here's our ratio. Our ratio is 2 to 71. So 2 to 71 must be equivalent to 10 to X. That's how we set it up. So we can solve for X now. X, if I do my cross multiplication, 2X actually, would be 71 times 10. Therefore, X would have to be 355. So this says that we need 355 grams of chlorine to react with 10 grams of hydrogen. And Y then, therefore, would be just the sum of those two, which would have to be 365 grams of hydrogen chloride. Okay, so there's one example. Let's do another example. And this is methane plus oxygen, giving you water plus carbon dioxide. Now, again, we need to first balance the equation. So I need to put a 2 here, make sure it's all balanced. So I have 4 oxygens on the left, 4 on the right, carbon's okay, hydrogen's good too. So again, first thing, we gotta make sure that we have the mass of our atoms. So we have 1 carbon atom, which weighs 12, and I have 4 hydrogen atoms, so methane weighs 16. I have 2 times 2, I have 4 oxygen atoms, which weigh 16 each. So there is a mass of 64. I have 2 times 2 hydrogen, so 2 hydrogen, which weighs 1 each, plus oxygen. So that would be 2 plus 16 is 18, times 2 is 36. Okay. And carbon dioxide is 1 carbon. Oops, put 1 carbon here, plus 2 times 16. So that would be 44. Okay. And if you look at the mass, there's a relative mass of 80 on the left, and there's a relative mass of 80 on the right. So again, imagine we had a scenario where we had consumed, let's say, 100 grams of methane, okay, and we want to know how much oxygen would be required. Well, very easy. Assuming we have enough oxygen, we could set up our ratios again. So our ratio for methane to oxygen would be 16 to 64. So if we used up 100 grams of methane, how much oxygen would be required in this case? So again, we set up our equation. So it would be 16x would be 64 times 100. And again, 16 goes into 64. Oh, no, it doesn't go into 64 4 times. I thought it did. No, it does actually. It does go into 64 4 times. So x therefore would be 400. So there you go. So then we know we need 400 grams of oxygen to react with 100 grams of methane. And then again, we can solve for y and z in the same manner. We could take our equation. Okay. We can see that the ratio of methane to water is 16 to 36, right? So again, 16 to 36, right? So when we set up our equation, methane to water, we have 16 over 36. And if we use up 100 grams of methane, how much, it's a y, how much water would we produce? Okay, and again, we do the same thing. We do the cross multiplication, so this gives us 16y would be 36 times 100. So 16y therefore would be 3,600, and then we could solve for y. So y would be then 3,600 divided by 16. So quickly, what would that be? So 3,600 divided by 16 would be, let's quickly do this, 3,600 divided by 16 is 225. Okay, so that gives us 225 grams of water. And then again, using the law of conservation of mass, now we know what Z is, because we have 500 on the left, and we must have 500 on the right. So that means Z must be 275. So if we use up 100 grams of methane, we must produce 275 grams of carbon dioxide. Okay, thank you so much.